All right, we're going to start here, 4.1, basic probability, launching into this new unit. The goals for today are to be able to distinguish between theoretical and experimental probability. You probably could do that already just after doing our activity, our dice rolling activity. And then to be able to determine theoretical probability given equally likely events. What is probability theory? It is the science of uncertainty. And as we move into the applications of inferential statistics, we will become more comfortable with uncertainty. So we spent all of Unit 3 on descriptive statistics. We were accounting for measures of center, calculating those, using lots of Google Sheets, measures of variation, standard deviation and range. All of that was just descriptive statistics. And now we're diving in, taking a deeper dive into inferential statistics. Theoretical probability, we've got an example here. Given the image of all possible outcomes for rolling two dice, we can determine you can shout out your guesses of what might go in these blanks. Yeah, good job. The theoretical probability of finding any given sum from, you can shout it out.
0 to 12?
2 to 12.
2 to 12, yep. The sums are anywhere from 2 to 12. And we're going to look at this example. What is the probability of rolling a sum of 8? Now, I gave you this beautiful visual. I will mention that this is great. It's a great reference. As you see any of your questions on rolling dice, and you're not quite sure how many different ways and what are the ways to roll two dice, this is just something good to come back to. You can't really tell because I did the black and white today, but these are red and black dice. So you'll notice that a 2 and a 3 is different than a 3 and a 2, and it makes it very obvious. They're slightly shaded here, but they're red and black in the text. So how many total possible outcomes are there for rolling two dice? Raise your hand for this one if you know. How many total possible outcomes?
There would be 12.
36, right? And they're all listed out here.
I just went, there's 6 rows down and 6 rows across.
Yeah. So if there's 36 possible outcomes, I'm going to just write that down here. It's going to come in handy in a second. And in answering this question, there's 3 different steps. Step 1 is find the total possible outcomes. So how many different ways can you roll the dice? Well, that was 36, right? And then step 2, write a ratio with, on top, we're going to write the number of ways the event can occur. So how many different ways can you roll an 8? I heard it shouted out. Go ahead. 5. And visually, you can look at this diagonal right here and see all of those different ways. So 5 out of 36. And then simplify your answer and then write it as a decimal. We can't simplify 536, but we can write it as a decimal. What's 5 divided by 36? What is it?
I don't know, I'm just guessing probably like 6.03.
Patrick?
5 divided by 36?
0.14? 5 divided by 36, yep.
Oh, yeah.
0.14 or 0.139. I'm going to go 3 decimal places there.
Okay.
We can also write that as 13.9%. So in the example above, notice that all chances are, kind of like the goal today, equally likely. To occur. Notice that we called rolling a sum of 8 the, is anybody paying close attention?
Ratio.
Not the ratio, but the words are above that, or right next to that.
No.
Right. Possible.
Ways.
Above the word possible.
Probability. Even if it can occur.
Who said it?
Which one?
Event.
I said, okay.
It's an event. Nice job. The desired outcome is called the event. So the probability for equally likely outcomes can always be calculated using the following. Probability of an event equals the number of ways the event can occur divided by the total number of possible outcomes. Pretty simple. The science of uncertainty is called
Maybe.
probability theory.
Oh, that's close.
Probability theory provides the mathematical basis for inferential statistics. Flip. Property number 1. Melena, will you read that one, please? On the basic properties of probabilities. A little bit of a tongue twister. Uh-huh.
The probability of an event is always between 0 and 1.
Thanks. That's key. So if I say the probability of rolling a 12 is 2, you're going to go, nope, not possible. It's got to be between 0 and 1. And when we think about probabilities, they are always, you can always create a percentage. So when we think about 0 as a percent, well, that's still 0. But if we think about 1 as a percent, move the decimal place 2 spots, it's 100%. And we're not dealing with over 100%. So keep that in mind. Property number 2, Jacob?
Probability in events that cannot occur is 0. In events that cannot occur is called impossible.
Right, such as rolling a 7 on a 6-sided die. Can happen. Property number 3, can you read that one for us, please? Sydney?
The probability of an event that must occur is 1. An event that must occur is called a certain event.
Excellent. So the probability of rolling somewhere between a 1 and a 6 on a 6-sided die. 1. Got to have one of those options when you roll a die. So in our second example, we're going to decide which of the following could possibly be a probability. So just give me like a thumbs up or a thumbs down. 5, 6. Is that a possible probability? I'm looking for 100% participation, a thumbs up or a thumbs down on 5, 6. Waiting for it. For everyone to give me a thumbs up or a thumbs down. Is 5, 6 a possible probability? Okay, everyone got it. Yes, nice job. It is between 0 and 1, so that's a possible probability. So 3.5, give me a thumbs up or a thumbs down. Is 3.5 a possible probability? Some of you have really sneaky ways of holding your thumbs, so that's okay. Be sneaky. You don't want everyone to know what you're putting. That's correct. It is not possible to have a probability greater than 1. 3.5 is not an option. 0. Is 0 a possible probability? Mixed bag on this one. Why do you think yes, Maddie? What? Between what?
0 and 1.
Thanks. 0 and 1 inclusive. It includes 0 and 1. So yes, it is a possible probability. Experimental probability, making a shift. Doing an experiment or simulation and then calculating the probability is called?
The answer.
That's right. The answer. Also known as Yes, well done. Simulation probability. Have you taken this class before? How did you know that? Just based on what we just did?
Well, experiment or simulation, it says right there.
Yep, it does. Good observation. So, when you're doing an experiment, you have real world factors that play into the outcome, including gravity, friction, economy, weather, all of these things that would make the results different. So, theoretical probability and experimental probability are rarely exactly the same. Take a look at 2 more examples. Example 3, will you read that one for us, please, Samantha?
A polling firm hired to estimate the likelihood of the passage of an upcoming referendum obtained the set of survey responses to make its estimate. The encoding system for the data is 1 for 2 equals against. If the referendum were held today, find the probability that would pass.
Thank you. So 4, that's the number 1. The code for 4 is 1. How many 1s are there?
12.
Nice. Always somebody counting ahead. And then against, which is the number 2, how many are against?
8.
8, correct. So the number that are 4 would be 12 out of, how many are there total? 20. 12 out of 20 is 0.6 or 60%. We could do the same with 8, right? 8 out of 20, which would be 0.4 or 40%. So the answer, the probability that it would pass is 60% or 0.6. Last example, similar to the first. If 2 balanced die are rolled, the possible outcomes can be represented as follows. Now we just have ordered pairs, yes.
Wouldn't 60% be the probability that someone was for it, and then 100% is the probability that would pass?
As long as they took the majority. Very good observation. Thanks for that.
Makes me think that he took this class.
He's a plant. Thanks, Orion. Man, you're killing it today. Determine the probability that sum of the dice is 10. Who's got it?
What?
Kylie.
There's 3. Yeah, it's 3.
Out of?
36.
Mm-hmm.
36.
Simplifies to 1/12, or what decimal? Go ahead, Jacob. 0.083, which is 8.3%. Nailed it. All done with the notes. Basic probability. On a scale of 1 to 5, how are you feeling about theoretical probability given equally likely outcomes? Equally likely events. Basically just calculating this. How are you feeling? Scale of 1 to 5. See a lot of confidence out there. Excellent.